That, that- so this means that in a simple language, a charge controller is like a regulator, like a power supply that is regulated, and you know there's a way it's going to function. The voltage is precise. We have them in digital forms. We have them, you can program some, or they work with values, and they will not go beyond the specifications given by the manufacturers. So if you say, okay, charge with 12 volts, is going to definitely charge with 12 volts, 13 amps, 12 amps, or different, all those parameters. So that is what it's going to do. And it's regulated, it's not going to overcharge unless if it is faulty. If anything should happen to battery outside the performance of the normal function of the charge controller, it means that charge controller is faulty. So that's just in a simple language what a charge controller is. Then changes. Next slide, please. Now, importance of choosing the right charge controller. It's very important for us to know that we have to choose the right charge controller to avoid some damages and some other things. Now, proper battery charging. You want a proper battery charging, it is important to choose the right charge controller. You want the battery life to be extended. That is, if you are told battery will last for under normal conditions, it should last for maybe 3 years. If there's a wrong charge controller, or you didn't choose the proper charge controller, the battery may not last for 6 months and it will get damaged. So the next one is minimizing the risk of system failure and downtime. So you need to choose the right charge controller to minimize that risk, because we have different brands. We have some that they don't even have brand names. Some maybe they are just experimental and everything, and nobody wants to experiment with failure. So we want to just get it right, and then because your customers will not listen to you when you get a charge controller that failed. So it's important to get a good brand and that will do the work effectively. Then the next one is optimization of PV charging efficiency and cable sizing. If you choose the right um, charge controller, you may be reducing the cable size, then the efficiency that is capturing the total energy from the solar panel and pushing them to the battery will have that available. Because if it's wrong, you may end up bringing power. Maybe the total power is supposed to be 2000 watts. At the end of the day, you are just getting maybe 500 watts due to wrong choice of a charge controller. So it's also very important. Then load management. Well, some charge controllers have load. They have port for load, where you can just put some. Maybe you want to charge a battery. You want to charge a phone. You want to put on a light like LED bulbs and all those. Then some charge controller too have interface with inverter. If you choose the right charge controller with the specific inverter, they may communicate, thereby making you to be able to use it during the day. If you have excess energy from the roof, because the inverter and the charge controller will communicate to know when to increase the power, which is not dangerous for the battery and all those function. So it's very important to choose the right charge controller. The next slide, please. Types of charge controllers. Maximum power point tracking, which we know as MPPT, is one of them. The second one is when we get to that. This one now is higher conversion efficiency. That's the one of the characteristics. That's one of the advantages, is having higher current and voltage limit, because you can connect solar panels in series. You can take a large number of panels in series and high voltage, and the current is small, and then you convert this to power. As the name implies, maximum power point. It will always be doing that, tracking the power point. The highest power is what we're going to extract from the panels and push it to the battery. So it also has it converts excess input voltage to current, because it can handle high voltage to make sure that it captures everything. It's still part of its function. Then it's
I
switching.
went through the something over the weekend. We have some exposures.
So it's suitable for large PV system. Yeah. So because you can connect many panels in series, you deal with high voltage. So you can, a charge controller like that can have many inputs, and then where you now have a lot of panels. So you don't need to spend much money on cables. It's easier. The connection will be neat, because you can connect maybe 10 panels, 15 panels in series, and like that. So in that case, you can now have multiple strings depending on the capacity of the charge controller itself. Well, it may be expensive. It may be more expensive because of one is pulse width modulation, which is PWM. It has lower efficiency. You know, it low current and PV voltage limit. It has low current and PV. Bring the whole voltage to the voltage of the battery. So at the end of the day, it may slash the power of the panel into two. So the losses in this one is higher than the MPPT. Then the solar input voltage must match the battery. Bank. So if you are using 12 volts, for instance, and then you want to use 24 volts solar panel, less than 50% capacity of the solar panel. So because it will bring it down to the battery voltage, because everything will now be connected in cable, or the design and other things is cheaper than the MPPT. Next slide, please. So still on that types of charge controllers, we have a charge controller which is inside an inverter itself. It's an hybrid system. This helps manage your battery in the best way, because it knows what to give to the battery at any point in time. It knows which one to give to your load. So the inverter, the charger, everything is inside a box, which is like a general manager to the whole system. So it's much better than having external charge controller connected to your batteries. So that's the next slide, please. Sizing a solar charge controller. What are the things you need to know? You need to know the nominal battery voltage. before you can choose a charge controller. Maximum PV input, power. That's maximum PV input power, maximum PV open circuit voltage of the charge controller. You need to know the operating range. Every charge controller has a specification, so you have to go through the specifications to know whether it matches what you want to do. Is it within or that battery you want to charge? So battery bank size, those are the things that determine if your battery bank is small, you don't need big charge control. So besides the for the solar to know about, we have the wattage, we have the operating voltage, current, and you have the open circuit voltage, which you are going to. That's what they meant by the open circuit voltage of the charge controller. You know how many you want to connect. So by the time you cascade them together, what is the total open circuit voltage? Is it higher? If they say it's 20 volts, you know that you should not connect more than 20 volts to the charge controller, or else you damage it. If it's 50 volts, if it's 145 volts, you know, whatever you want to do should be under the value that is given by the manufacturer. Then you have the for the MPPT itself, you can see the 60 volts, the range is given that it's going to operate from between 60 volts to 115. But the maximum open circuit voltage is given as 145, which means you've seen it's clearly stated. You just operate within the range that is given. And the maximum array of solar panel given is there. So also given, you know, as 1,600 watts or 800 watts or 3,200 watts. So all these, then the nominal voltage, the nominal battery voltage is also given. Are you dealing with 24 volt system? Are you dealing with 12 volt system or 48 volt system? So all these are very important. Next slide, please. Factors to consider in choosing a charge controller. Compatibility with battery type. You know, it has to be compatible with the battery you want to charge. Is it wet cell? Is it flooded? Is it this? So all those parameters will be inside it. So you must be sure that it's compatible with battery. If not so, to damage the battery. Then operating voltage rating. You must know the operating voltage rating of the system should not be out of the range. So if it is 12 volts, you operate within the range. Just then the next one is a current rating. You know the current rating, so that you don't overload it, can damage the charge controller itself. So charge controller type, is it PWM or MPPT that you want to use, you have your reasons to choose. So depending on the nature of the project you are handling and the components you have surrounding it. Protection features, you know, of that the charge controller itself. So some have a reverse polarity, no, all those, no. So that if there's any mistake, you don't need to just throw it away. If it's overloaded, you should just shut down and come back on. You know, if there's a breaker, if the breaker will just trip, you know, there could be any different types of protections around it. Then the brand and quality. Of course, some people will say, you say the buy name. It's good to just go for a good brand that will not give you problem. Next. This is Genx 60 amps MPPT charge controller. And these are the features below. It is intelligent maximum power point tracking technology. Then it's compatible with 12 volts, 24 volts, or 48 volt system. As if your inverter is 12 volts or 24 volts, or you can connect it, you know, and is a automatic battery voltage detection. Once you connect to the battery, immediately it will sense that, oh, you are operating with 12 volts, and it will adapt to it. So that when by the time you connect your panel, everything is there, it will just charge accordingly. Of course, you have to program it, it's programmable. Then three-stage charging optimizes battery performance. Yes, that's the charging algorithm, charging process. There are different ways to charge batteries. So it's having three steps, which is very good for battery life. Now, the first one could be bulk. It will go to absorption, then it will go to float, where it's going to rest after fully charged. Then maximum efficiency is up to 98%. So which means it's very efficient, not compared to maybe 50 or so. So it's going to charge properly. Overcharge protection is available in it, so it's not going to overcharge your battery. So these are features you get in it. It's suitable for different battery type. You see AGM, you see wet cell is in there, and you have the option of being able to program it yourself according to the specification of the particular battery you want to deal with. Then you choose a particular settings where you can set. Next. This is grow at 80 amps, 100 amps, 120 amps MPPT charge controller. We have them in that capacity. It's also auto range in terms of detecting battery that you connected it to. It has a reverse polarity protection, but it's important not to make that mistake of reversing the polarity. But it's having that protection inside it. It supports Wi-Fi and GPRS remote monitoring. It supports BTS for battery compensation, multi-stage charging, just like the other one. The stages in charging for best performance of battery. Then it's suitable for different battery type as well. Next. Key components for charge controller installation. PV breakers is very important. That's the breaker between the PV and the charge controller. Then battery breaker is the breaker between the battery and the charge controller itself. DC surge protector, that's this is connected at the input from solar, so that if there is a surge, it handles that instead of it going to maybe lightning strike or something like that can damage the charge controller. It attacks it just before it enters the inverter. Then you have cables. You need to understand that the size of cable, if you choose proper gauge of cable, then it will affect the charging current and everything. So it may even lead to damage of the charge controller. So cable lugs has to be properly fixed at the appropriate places on top of the battery, at the terminals of the charge controller if it's required. It's very important. Some charge controller has MC4 connectors at the input, which you just plug, which makes it like plug and play. Very important. Next. Common charge controllers error to avoid. Do not connect AC load to a charge controller. A charge controller is a DC regulator, like I told you. And it doesn't do anything with AC. Do not mount charge controller far from the battery. If you do that, you need to invest in cable, and then there'll be energy loss through the cable, So all this, it has to be normal. If it's closer, then the efficiency will be high. Do not turn off battery breaker when solar input is available. This is very important. If you do that when the charge controller is connected and everything is working, you just get there, you switch off the battery breaker, the charge controller is just going to get damaged. It's going to get damaged. So it's part of the procedure for commissioning or decommissioning. You should avoid that. Avoid connecting an external charge controller with hybrid inverters on the same battery bank. This is to avoid overcharging, because when the other one, if they are not interfaced together, they don't communicate together. If you do that, they will send their programmed value of current into the battery, and then that will cause overcharging. always follow instruction in user manual. Deliver a certain amount which is going to send. It's not going to take more than that. If you say, okay, charge my battery with 20 amps, and you have a provision that can deliver even 120 or 1000 amps, then it will only deliver that 20 amps into your battery, and the rest is waste. But if it is an hybrid system, you can utilize the rest by putting some loads during that time when you know that you have excess generation, which is advantageous for you.
All right. So the next question is saying, as hi team, as regards not using an external charge controller with a hybrid inverter, what about if we have a bigger battery bank with bus bar linking them up? I think you have answered this question. Is it? Engineer Kunle, are you there?
Okay, I didn't get what you said now. What about
So he's saying, as regards not using an external charge controller
please
with a hybrid inverter, what about if we have bigger battery bank with
repeat
bus
that?
bar linking them up?
Okay. That is, and that you can do that because you already know that there is no way you can cause overcharge to the battery. The battery bank is even oversized, so you can bring in one external charge controller. That is a problem. You may need another one, or you may need it depends. So all what we are saying is just to be more conscious of overcharging. So if your battery bank is too big, you can introduce the external charge controller instead of changing the inverter, or instead of just to be economical. But the best way is to make sure that you manage them with um and it's not introducing any threats. It's not dangerous because even with the external charge controller, you cannot overcharge it, then you are good to go.
Okay, thank you very much, Engineer K. There is one last one.
When you are
What's
not charging them properly, those batteries are meant to be charged and properly charged.
all right? Thank you.
Yeah,
Thank you,
please, I want to
Engineer
ask
K.
you a simple question. I raised my
Okay, so
hand.
can we have I think Betronics is
Johnson
actually
Olaji.
hello, just hold on, sir. Hold on a second, sir. Betronics actually put a comment in the chat box saying that he had an experience yesterday. He would want to ask a question in that regard. So after him, we take yours and then we can wrap it up. Thank you, sir. So Betronics, you can unmute yourself now.
Hello, good morning. Can you hear me,
Good
please?
morning.
Good
Yes, I
morning,
can.
sir. We can hear you.
Okay, thank you very much for this webinar. I really appreciate it. In fact, I just stumbled into it while going through my WhatsApp status. Then I found your company. Thank you very much. And yesterday, that was like early this month, the middle of this month, I was introduced to a client who told me he wanted to replace his battery. And I was able to get a battery for the client. And like a week later, I called to know, please, what's the nature of how is the battery serving you? And she said, wow, thank God it's a new battery. There's no problem. Only for like last week, Saturday, I got a call from this client that all of a sudden, the new battery you bought from me just went down. And I told them, something is or something else. In fact, it was a very big tug of war. Imagine you is down. But one thing, her charge controller was not good, and she's this kind of meticulous in nature. So yesterday, I left my house to Ogun State to check the system, and I discovered that first of all, because I didn't do the installation in the first place, I had to climb on top of the roof, took my solar panel testing device, and I tested all the panels one after the other, and all the panels were okay. They were delivering at least what I'm supposed to get. A 300-watt panel as at early in the morning was giving me close to 180, 200 watts from the sun. I said, fine. But when I connected these panels and I go to the MPPT, what I'm getting from the MPPT from the solar is just 24 watts. And I don't know what could really be the problem. That is why I had to say, please, let me put this across. However, I had to help them resolve it because I discovered in the first place that her inverter was an MPPT. I mean, it was a hybrid inverter, which means it has a charge controller. But the person that did this installation initially for her had to get an external charge controller. So I advised this woman, I said, please, this your inverter is a hybrid inverter. If you don't mind, I will connect all this solar to this your inverter and it will work. After long argument, because she keep insisting that no, the person that did this job for me in the first place is a professional, and there is no way I will come and do something else. I assured her, for someone to recommend me to you, that means this person have also tested me. Can you give me a time to just do what I wanted to do? After long pacifying her, she accepted. I disconnected the MPPT I saw there and connect these panels to the inbuilt controller of the inverter, and everything started working. In fact, as of this morning, I just called her. Did your inverter shut down? She said no. Thank you for coming to resolve this problem. Now, what do you think could be wrong with that charge controller? When I'm getting what I'm supposed to get from the sun, from the panels, at least I have 4 panels. I made 4 panels there. If each panel is generating close to 180 watts, I'm expecting from the controller to get nothing less than 600 watts. But what I got that morning was 24 watts. Can you throw more light on what could be wrong or what is the problem with the system? Please.
Okay, yeah, thank you for your question. Then number one thing I can say is that it's obvious that the problem is with that charge controller section, whether the components that are connected to it, or it could be circuit breaker not allowing enough current, maybe current to the battery or current to the charge controller itself, or that charge controller itself is faulty, or it was not programmed to deliver more than, because at times some people won't program this in and they will say, why is it not giving more than 10 amps? If by default it was programmed to deliver 10 amps, you can't do more than that. If you like connect 1000 panels, it will not deliver more than that 10 amps. That may not mean that the charge controller is bad, but you have to reconfigure it according to the system on site. So that's it. Or if the specifications is right, then I think the problem is with that charge controller and component around it. That's specification in terms of a choice of voltage, the input voltage range, and all of that, all everything there. That's the current, the voltage, and everything. If all those things parameters are okay, then there is no reason why it should not work if the charge controller and the components surrounding it are okay. So that's just what I can say.
All right, thank you very much, Engineer Kunle. Can we take Mr. Johnson Olajuibe now,
Yeah,
so that we can
thank you.
wrap it up? Thank you.
Yeah, thank you. I pray that Genx can do more of this, especially for those of us in the training. It has really been very helpful. Please, two quick things. Please, are we going to get the presentation?
Just like I said earlier, the presentation is going to be uploaded on our YouTube channel, so you can always have to watch it there.
Okay, so Genx has a YouTube channel.
Yes, you can always check Genx Technologies on YouTube.
Okay. Oh, thank you for that information. Then please, secondly, this discussion on the hybrid charge controller. Oh, sorry. Yeah. Is it a standalone charge controller or hybrid inverter? Which one is actually, will you advise? Is one better than the other? So that in case you want to use it for personal use or commercial use, which one is better? Do we maintain the standalone or the hybrid?
Well, you're welcome, sir. If you have a system that is running and is working perfectly, and you confirm that the batteries are not being overcharged, maybe the system because of the way they connected them together, you are good to go. But if you discover that the battery is overcharged or is likely to be harmed because you are using external charge controller, I will advise that you get a hybrid system. But if you have a set of batteries, because we have different connections out there. There are some inverters that they are just inverter, they don't charge. Then it is you that will connect the inverter. His own is just to take energy from the battery. Then that one, you can say, okay, if you don't want to change it, you can get external charge controller. But if you get external charge controller, there will be losses because you want to use your system during the day when the charge controller is also generating. If you have enough solar panel, you won't be able to do that because the moment you start using it, you can't get optimal charge energy going into the battery. So it's always best. It depends on what is available and what you want to get, or what's your discovery on the available system now.
How about if you are doing a new system? If you are installing a new, if it's a new installation,